So this line that's created is using these residuals and it's trying to minimize all of the residuals simultaneously. And that creates the equation for our line. So as a reminder from our algebra days, if we're creating an equation for a line, there was a setup where we say it's y equals mx plus b, where m describes the slope of our data, x is our independent variable, and b described the y-intercept, which is the idea of where do we intersect with the y-axis. So for least square regression line, we're going to see the same setup. The notation just changes a little bit. Here is the setup for our equation of the line. So where we use y usually, we use the symbol y hat. And y hat, it gets the little hat because specifically it's predictions for y. In terms of graphs and algebra, it's that we had this function. We knew if we had this value for x, based on the formula, it had to be y. But again, with our data, this line is just making predictions, in that where this value here at an output would be a prediction, this is our actual y value. So in terms of coordinates, this would be x with a y hat on the prediction line, and then our data value, this is actually x and y. So this would not have a y hat. So the notation changes based on, is it a prediction or is it what we actually observed? So y hat is for predicted values given a certain value for x. Then instead of m for slope, we use this b with a subscript of 1. So b is the slope of the regression line. If our slope is positive, it'll be positive. If our slope is negative, then that value will be negative as well. Something we can do is describe our slope in context. And the idea is slope tells us how y is changing, how our outputs change as we change x. So how we often describe slope is if we increase our x value by 1, our slope is the change in y. The idea being if we just change, in this case, our distance by 1 unit, so just go up by 1 mile, the slope is telling us how our airfare changes. And if it's positive, it's describing an increase in airfare. If we had a negative slope, it would be describing a decrease in airfare. So we can use that sign to throw in the word increase versus decrease in there. Another piece we can describe, so there's our variable x, as we have because we need our input, and then plus, and this is our y-intercept. So also b, but now it gets a subscript of 0 there. And b sub 0 is our y-intercept of the regression line. So it's our output when x equals 0. It only occurs when we plug in x equals 0, everything there wipes out, so all we have is our prediction equals b sub 0. So if x is 0, b sub 0 is the value of y. Now, slope we can always put into context. Sometimes this intercept doesn't make sense. Sometimes it can go all the way to the negative region, and often in terms of context, like to have negative airfare, wouldn't make sense. So sometimes when we're trying to interpret these, slope you can always do. Sometimes you'll try to interpret y-intercept, and it just won't make sense contextually. So this is how we work with the setup of our regression line and how we can interpret the different pieces. What I'm going to do in the next video is go through our next example working with this airfare data, and I'll show you how to find this equation of the line using technology. Because once we have this equation, then we can start looking at these predictions along the line.